Hello, this is Adam Skripchak from STC. If you're a seasoned modeler, you may already know that you can extend the system modeling language using stereotypes and profiles for your specific project and domain needs. But did you know that some useful extensions are provided by the specification itself? Well, these are the non-normative extensions to the language, and in this series we'll go over them and their uses. But first, what are non-normative extensions? Non-normative extensions are useful additions to the system's modeling language that may be considered for standardization in the future and consist of stereotypes and model libraries that are organized by major diagram types, like activity diagrams and requirement diagrams. Here's a brief list of the ones available in the current SysML version 1.7 specification. But for today, we're going to focus on the requirement extensions. So what are the requirement extensions? Well, the extended requirements start as specializations of the base requirement provided by the SysML profile. That's the one here all the way at the top. Below that, we've got the extended requirement, and this adds useful attributes for modelers to use, such as source, risk, and verify method. Source may be used to, say, cite a specific passage from a source document that you're using for your requirement. Risk comes in low, medium, and high risk and can be used to help ascertain the stability of a requirement and its risk of change. So if you have a high risk of change, if you have a TBD value in there that needs to be fleshed out further, you may have a medium risk that has a TBR value that needs to be reviewed and approved by a customer, or you may have a low risk of change where the requirement is relatively stable. The verify method includes inspection, analysis, test, and demonstration, and can be used to support your verification strategy for your requirements. Here below the extended requirement, we've got its specializations. So it inherits these attributes and can be used to support these different requirement categories. So here we have design constraint, physical requirement, interface requirement, functional requirement, and performance requirement. Keep in mind, if you're using Cameo System Modeler, it only has validation rules for the 4 requirements here: design constraint, functional requirement, interface requirement, and performance requirement. So the physical requirement is the only one of the 5 that does not have a validation rule enforcing what may satisfy it. So what does satisfaction mean in SysML? Well, in short, it asserts that a system or its component fulfills a requirement. Proof of this is handled by a verify relationship to a test case or other element that is used to verify the requirement. So satisfaction means a requirement has been implemented and fulfilled, and verification proves that's the case. The first requirement we'll look at is the extended requirement. Here we have a source document represented as an artifact element with the document stereotype applied, and we have extended requirement tracing to it. And here we can see the different compartments. We have a risk for this requirement changing being medium. We have the source citing a specific page and paragraph from the document itself that has the actual passage copied and pasted in here. And then we have the formal text of the requirement with the shall statement and the range of values that it has to comply with. And then lastly, we've got the verify method here that says that we're going to verify this requirement using a test. Next up, we have the functional requirement. The functional requirement covers basically a function the system must perform and can only be satisfied by a behavior or an operation. So in this example here, we have a coffee maker system, and there's a functional requirement to brew coffee. The system shall brew coffee. And here we have a coffee maker block that has an operation that satisfies this requirement. So by saying that this block has an operation satisfies that the coffee maker will have a function that is called brew coffee. For operations, we have a behavior here, an activity called brew coffee, and because it is the method of the operation, it is also owned by the coffee maker block. This behavior can also be dependent on a use case, which then refines the requirement. So it's a couple different ways to show the different paths and the different relationships you could use to relate from a requirement being provided to a use case to an activity to actually satisfying the requirement by having it as a feature of your block. In this example, we have the alternative. So here we have the requirement being satisfied by a behavior. Some modelers may elect to use allocation as a method by which they marry form and function. So in this example, we have a use case that refines the function of brewing coffee, and this behavior is dependent on that use case, and this behavior will satisfy this requirement but also be allocated to the coffee maker. The validation rules will still run for both, so if you click on validation, it'll actually check to make sure it's done correctly. If you use any other element to try to satisfy this requirement, that is not a behavior or an operation, the validation suite will actually generate an error. So next up, let's look at the performance requirement. The performance requirement specifies a value that quantitatively measures the extent a system or a system part satisfies a required capability or condition and is satisfied by a value property. Since value properties describe quantifiable characteristics of a block, the performance requirement may need further refinement using a constraint property on the block itself. In this example here, we have a performance requirement for the missile range minimum, and we have a value property on the missile system that says range. And that value property will satisfy the requirement. But in order to further refine this, using a constraint property and a constraint block, we can actually capture the constraint itself. So if the requirement says the system shall have a minimum range of 300 kilometers, then you can actually specify the range constraint here with this constraint equation and its parameter. And this can be used to refine this requirement. And using a parametric diagram, we can actually even bind the value property to the constraint property using a binding connector. The next requirement we'll look at is the physical requirement. Physical requirements specify the physical characteristics and constraints of a system or its parts and are satisfied by a structural feature. Structural features are parts, ports, and properties of a block. And of those properties, you may have value properties, constraint properties, and even reference properties. Here in this example, we have a mass physical constraint. So the water tank shall have a mass of less than 10 kilograms. Just like the performance requirement, you may specify that attribute using a value property. So here we have the value property for mass, and it's constrained by a constraint property called mass constraint or max mass. And here it's constrained by a constraint property called max mass typed by the mass constraint block. So here, again, we could use a parametric diagram to relate the mass value property by a binding connector to the constraint property. Lastly, we have the design constraint requirement. Design constraint requirements are requirements that specify a technological constraint on the implementation of a system or a system part. They may be only satisfied by a part property or a block. In this example, we have an engine requirement for an aircraft. The aircraft shall have at least 2 engines for redundancy. Here we have the aircraft block. It has a part property called engine, and it's typed by the block engine below. We also even have a multiplicity here saying that it has 2 engines. And this part property can then satisfy this requirement. The engine may also satisfy the requirement in pass validation, so that's an option as well. However, it may be preferred to use the part property as your means of satisfaction, since it actually indicates that the engine is actually a composite component, because it actually indicates that the engine is a component of the aircraft, and we have 2 of them. So in this video, we covered the extended requirements in SysML version 1.7, but what about SysML version 2? Will these extended requirements make it into the new specification? The answer is yes and no. The concept of a requirement extension is supported in SysML version 2 using the metadata extension mechanism and model libraries. So while the specific requirement categories such as extended requirement and its specializations may not be present in the new specification, you can recreate them using the metadata extensions. Metadata extensions in SysML version 2 are the equivalent of stereotypes as we know them today in SysML version 1.7. You can recreate the attributes needed and the requirement categories and place them in a model library for reuse across multiple projects in your organization or domain.